Hi, I'm Suyeon Wy from Gongun University in South Korea. I'm going to present about a research for a new web-based application for building deep learning models to solve biological problems. Deep learning is one class of machine learning algorithms that can extract important features from raw data by themselves in an end-to-end method. Accumulation of biological data and improvement of computational power and learning algorithms have enabled the use of deep learning for solving many biological problems. To allow researchers to build deep learning models without programming, diverse deep learning platforms have been developed. However, biologists are still discouraged from applying deep learning in their research because existing deep learning platforms only focus on implementing general deep learning models. Therefore, a new deep learning platform that can solve the existing limitations is necessary. So in this research, we developed a user-friendly and easy-to-use web-based application called DLEB for building deep learning models specialized for biologists. DLEB provides a web interface for designing and constructing deep learning models. DLEB supports diverse types of layers, activation functions, and pre-trained models. Users can easily set various parameters for each layer. For users' convenience, DLEB provides commonly used parameter values as defaults. Designed models are visualized as a graph structure where nodes represent layers consisting of the model and edges represent connections among layers. Moreover, DLEB can calculate and display numbers of layers and parameters in deep learning models. Those numbers are updated in real time during model construction and can be valuable information for users to reduce the size of the model or the time needed for training. Additionally, DLEB provides diverse template models and recommends deep learning models for researchers with little experience in designing deep learning models. DLEB supports widely used deep learning models as templates, including DNN, CNN, RNN, GAN, and autoencoder. DLEB also recommends deep learning models appropriate for a selected learning task with its available input data. Given the model structure and user-defined parameters, DLEB generates Python code in the server-side module for running directly without additional programming. The Python code consists of multiple parts. First, the output code includes the step for pre-processing input biological data. It is difficult to directly use data in formats specialized for biological data, such as FASTA, BAM, BGRIC, VCF, and GFF as input data for deep learning models. Therefore, DLEB generates Python code for calculating biological features and summarizing them in a matrix format. For model training and evaluation, the preprocessed dataset can be divided into training, validation, and test datasets. Second, the designed deep learning models are implemented. For implementation, DLEB uses TensorFlow 2 and Keras, which are the two most popular deep learning libraries. Lastly, the final code includes code for training, testing, monitoring, and saving models. Therefore, all processes from data preprocessing to model training can be executed directly by running just the generated Python code. For applying deep learning models constructed in DLEB, users can not only use their machine, but also use Google Colab, which is also supported by DLEB. For training and testing deep learning models, appropriate datasets are required. However, there are no example datasets specialized for evaluating deep learning models designed for biological input data. Therefore, DLEB provides example biological datasets that researchers have used in deep learning models in recent biological studies. DLEB supports example datasets with diverse types including sequence, alignment, signal, and image, and provides example deep learning models for each data type. In this research, we developed DLEB, which is a web application for designing and implementing deep learning models for biologists. It helps users design and implement deep learning models with an easy-to-use web interface and various useful functions. DLEB can serve as a highly valuable platform for easily applying deep learning to solve many important biological problems. DLEB is now freely available at the URL in the poster, or you can just scan the QR code for accessing DLEB. Thank you for listening.